This is R.D. Sharma solution, class 12, chapter 19. Exercises 19.23. We are taking indefinite integrals. Now in this exercise, we will be using a lot of trigonometry. So the trigonometric identities, wherever it will come, I will write it. I will show it to you so that you learn it for better. Now what do we do? 1 by 5 plus 4 cos x we cannot integrate directly. So we have to devise a plan or devise an approach so that we can make it integrable. We know that cos x is equal to 1 minus tan square x by 2 by 1 plus tan square x by 2. Because cos 2x is 1 minus tan square x by 1 plus tan square x. You already know that. So I'm just writing it because this is going to be used a lot in the other questions which are going to be followed. So I'm just showing you the denominator right now. It's 5 plus 4 and here I'm writing this one 1 minus tan square x by 2 1 plus tan square x by 2. So I'm just writing it in short so that you understand that what exactly this change or this replacement is going out to be. So 5 into 1 plus tan square x by 2, I am just taking the LCM. 4 into 1 minus tan square x by 2, and denominator we have 1 plus tan square x by 2. So 1 plus tan square x by 2. So this is only the denominator which I am talking about right now. So let's resolve this one. 5 plus 5 tan square x by 2 plus 4 and 4 minus 4 tan square x by 2. So what do we got? So 5t square minus 4t square is equal to t square. So it's actually tan square x by 2. 5 plus 4 is 9. So you can write it as tan x by 2 whole square. So this is tan x by 2 whole square. And this is 3 square. Now this is just the denominator. And this denominator, that is tan square x by 2 plus 3 square divided by 1 plus tan square x by 2. So this 1 plus tan square x by 2 will go up in the numerator. So we have this tan square x by 2 plus 3 square, and since it is 1 by tan square x by 2 plus 3 square divided by 1 plus tan square x by 2, so 1 plus tan square x by 2 will go in the numerator. Now 1 plus tan square x by 2, you already know that sec square theta is equal to 1 plus tan square theta. So we can directly write the numerator as sec square x by 2, and this tan square x by 2 plus 3 square. So it is tan x by 2, and this, because now we are going to integrate it. So this left part only was for your understanding. Actual integration will start from here. Now when we take this t equals to tan x by 2, this dt by dx will be equal to tan x by 2 is sec square x by 2. So sec square x by 2, and x by 2 differentiation will be 1 by 2. So this is 1 by 2. This 2 goes here, so it will be 2 dt will be equal to sec square x by 2 dx, because we actually need sec square x by 2 in the numerator. And this replacement will be what? It will be 2 dt. When we take t equals to tan x by 2, sec square x by 2 will be sec square x by 2 dx will be 2 dt. So I am writing 2 dt 2 in front of the integration. Now we have taken t equals to tan x by 2, so t square plus 3 square it will be. Now we have seen in the previous exercises also, this dx by x square plus a square, the direct result we have, it's 1 by a tan inverse x by a. So this is 2 integration of, and after integration it will be 1 by a. What is a? 3. Tan inverse x by a. What is x here? T. A is 3. So this will be 2 by 3 tan inverse t by 3. So tan inverse, what is t here? T was tan x by 2. So let's write tan x by 2 here, and 3 in the denominator. So divided by 3 plus constant of integration. So let me show you the result here. This is the stepwise solution process of the question we have seen, and you need to follow this kind of process. All these English and symbols have to be written. Now we have just dealt with a cos, but now this question is having a sine. So we are now aware that we have to change sign in such form so that this integration is easier. And we know that 2 sin x is 2 tan x by 2 divided by 1 plus tan square x by 2. So 2 tan x by 2 by 1 plus tan square x by 2, we can write sin x. So 1 by 5 minus 4 sin x. I am writing now the denominator 4 minus 4, 5 minus 4 into 2 tan x by 2 divided by 1 plus tan square x by 2. So let's write it in short and try to solve what do we get in the denominator. So I'm taking the LCM, 5 into 1 plus tan square x by 2, that is 5 into 1 plus t square, and minus 8 tan x by 2. Please remember 5, this 1 plus t square is with 5. Then we have this 8t, that is t I'm writing for tan x by 2. So we have 5 plus 5t square minus 8t. So 5t square minus 8t plus 5. So let's make it as a perfect square first. Now denominator will also have, because we have just taken the denominator, denominator will also have 1 plus tan square x by 2. So let me write it here, 5t square minus 8t, please remember t is tan x by 2 here. And this 1 plus tan square x by 2 will go up in the numerator. So 1 plus tan square x by 2 divided by 5 tan square x by 2 minus 8 tan x by 2 plus 5. So now let me just replace t by tan x by 2. So 1 plus tan square x by 2 here divided by 5 tan square x by 2 minus 8 tan x by 2 plus 5. So this tan x by 2, let's take it as t. dt by dx will be what? Tan x by 2 is sec square x by 2. And the differentiation of x by 2 will be half. So this will be 2 dt equals to sec square x by 2 into dx. Now this numerator 1 plus tan square x by 2 is already sec square x by 2 because this is the identity. So in place of 1 plus tan square x by 2 you can write sec square x by 2, and then in your denominator you have 5 tan square x by 2 minus 8 tan x by 2 plus 5, and this sec square x by 2 you can write it as 2 dt now. So 2 dt, and sec square x by 2 if it is 2 dt because t was taken as tan x by 2. So this will be 5 t square minus 8t plus 5. Now integration has become so easy because this is the denominator, we just have to make it as a perfect square. So let's make this as a perfect square, 5t square minus 8t plus 5. So 5 I'm taking outside, and the only thing is when you take anything outside it has to be divided by every term. So t square minus 8t by 5 plus 1 has come, because 5t square by 5 is t square, 8t by 5 is 8t by 5, and 5 by 5 is 1. So now 2 dt was there, so 2 I have taken out, 5 we have taken here, so 5 I have taken out, 2 by 5 has come in front of integration. Now this 8 by 5 has to be divided by 2 now and square it. So this is how we add and subtract terms to make it as a perfect square. Take the coefficient of the t and divide it by 2 and square it and add it and subtract it. So you have t minus 4 by 5 whole square, a square plus b square minus 2ab, and then 1 minus 4 by 5 whole square, that is 1 minus 16 by 25. So it will be 25 minus 16 by 25. So this is going to be 9 by 25. It's 3 square and 5 square. So you can write it as 3 by 5 whole square. This is 3 square, this is 5 square, 3 by 5 whole square. So let me write it here now. 2 by 5, you know how this constant we have taken outside. Now dt by t minus 4 by 5 whole square plus 3 by 5 whole square. Now this t minus 4 by 5 can be written as u. du by dt will be equal to what? 1. So du will be equal to dt. So even if you take it as x, because some may ask this question that if you are applying this formula dx by x square plus a square, t minus 4 by 5 is not equivalent to x, it has 4 by 5 content extra. But I've showed you that if you take it as u also, some term, du and dt will be equal. So you can take t minus 4 by 5 equivalent to x and apply the formula in the same way. So this shows that t minus 4 by 5 can be taken as only x. So let's use this formula. 2 by 5 was already there. 1 by a, that is 1 by 3 by 5, tan inverse, and x by a, what is x? T minus 4 by 5 divided by and 3 by 5. So let's resolve this, the front thing. This 5 gets cancelled, you have 2 by 3 tan inverse. Now t minus 4 by 5, it will be what? 5t minus 4 by 5. In the denominator we have 3 by 5, so 5 gets cancelled. It's 5t minus 4 by 3. So this will be 5t minus 4 by 3. Now what was t initially? It was tan x by 2, remember? So I'm just writing here, there are certain steps you have to write. I'll show you what you have to do. So 5 tan x by 2 minus 4 by 3 plus constant of integration, and that's your final result. Now this is how you're going to do this. It's very important to write, because knowing is one aspect and writing it on a paper in an examination is very important. So we have just seen a question like this, and there are certain questions we'll do in order to let you know that how it is to be done, and let's see how this question will be done. Now you are aware how to write this sin x. So let me write the formula again so that it stamps on your brain, the neural circuit you have. To tan x by 2 by 1 plus tan square x by 2, that is how sin x can be written. Now let me just take this tan x by 2 as t, just to show you that how this denominator will be formed. So 1 by 1 minus 2, sin x can be written as 2 tan x by 2 divided by 1 plus tan square x by 2. I am writing just t for it, just to show you. Now just take the LCM here. So 1 plus tan square minus 4t, 1 plus t square goes here, minus 2 to the 4t. 1 plus t square in the denominator goes up. So what do you get? 1 plus tan square x by 2. Now I am just writing actual thing, tan square x by 2. And then we have 1 plus t square minus 4t. So you can write this as t square minus 4t plus 1. So tan square x by 2 minus 4 tan x by 2 plus 1. Okay, 1 plus tan square x by 2 is directly sec square x by 2. You already know this formula. Now take this t and write it as tan x by 2. So dt by dx will be equal to what? Tan x by 2 will be sec square x by 2. That is, dt will be equal to, and x by 2 also needs to be differentiated. That will come as half. So 2 dt will be equal to sec square x by 2 dx. So this is whole dx. Sec square x by 2 dx can be written as 2 dt now after replacement or after taking t equals to tan x by 2. Denominator will become t square minus 4t plus 1. T is this tan x by 2 has been taken as t. Now we have to make this t square minus 4t plus 1 as perfect square. What is the coefficient of t? Which is 4. Now this divided by 2 is 2, and now you can square it and add it in subtracting. So you can add plus and subtract, add 4 and subtract 4. So a square plus b square plus 2ab t plus t minus 2 whole square. This is not t plus 2 whole square. I'll just change it. So t minus 2 whole square minus root 3 whole square. So you can write it as 2 integration dt divided by t minus 2 whole square minus root 3 whole square. Okay, you already know the formula of integration of dx by x square minus a square. So this will be dx by x square minus a square. It will be 1 by 2a log and x minus a by x plus a. And that has to be in the modulus. And this log is not just log, simple log, it's ln, log base e. That's why you can write it as ln. So 1 by 2a, what is 1 by 2a? 2 root 3 ln, and then you have the modulus sign, and you can write this as x minus a by x plus a. So I'm writing it as t minus 2 minus root 3 and t minus 2 plus root 3. So t minus 2 minus root 3. It's not t plus 2. Please remember, I'm just going to change it. Whatever I'm saying is the correct thing. So now let us write it as tan x by 2. Tan x by 2 minus 2 minus root 3 and tan x by 2 minus 2 plus root 3 plus constant of integration. Okay, 2 gets cancelled, you get 1 by root 3. So 1 by root 3 ln tan x by 2, I'll just change it as negative. This is negative. And actually this was t minus 2 whole square as I indicated you earlier. So I'm just changing the sign because it was the actual sign. I have to put it earlier. But anyways, you understand the things now. So tan square x by 2 minus 2 plus 3 root 3. So this is your final result. This is all minus. Okay, this is the result which I was talking about, and this is the way you are going to write. There are certain things, that is, the explanation will not be like this. It will be more in an exploratory way. That is, I have to explain you a lot. But when you are writing actually for exam or your classwork, you have to write exactly like this, almost like this. Now in this question, we have cos x. So you already know how to convert this cos x in terms of tan. So cos x will be equal to 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Now this can be just placed here. So I will just take this tan x by 2 as t just to show you what will come. So 1 by 4 cos x can be replaced as 1 minus tan square x by 2, that is 1 minus t square, divided by 1 plus t square and minus 1. So this will be 1 by 4 minus 4t square and minus 1 minus t square. Okay, this 1 plus t square in the denominator will go upstairs, that is 1 plus t square. So 1 plus tan square x by 2 it will be. In the denominator you have minus 4t square and minus t square will give you what? It will be minus 5t square. And 4 minus 1 will give you 3. So you can have a 3 here. 3 minus 5t square. 3 minus 5 tan square x by 2. So now you know this 1 plus tan square x by 2 is simply sec square x by 2. And this 3 minus 5 tan x by 2 can be written as root 3 whole square minus, and this 5 tan square x by 2 can be written as root 5 tan x by 2 whole square. You just have to make it as a perfect square, even if you have to include a root by yourself. Now previously we have taken always t equals to tan x by 2 whenever we encounter this. But now we have root 5 tan x by 2 and we need to get rid of this in order to make it equivalent to integrable equations we have. So now I'm taking t equals to root 5 tan x by 2, dt by dx will be equal to what? Root 5. Tan x by 2 will be sec square x by 2, and we have to differentiate x by 2 also, that will give you 1 by 2. So this will be root 5 by 2. Now 2 by root 5 will come on left, 2 by root 5 here, and dt this one, and sec square x by 2 dx will come here, sec square x by 2 and dx. So the numerator, what was that? Sec square x by 2 dx, it will be 2 by root 5 dt. So integration, so sec square x by 2 dx we have written now by placing 2 by root 5 into dt. Root 3 whole square minus t square. Now we have a direct result. You know already the result. Dx by a square minus x square, and that will give you 1 by 2a log ln, basically log base e. And since it is a square minus x square, there will be a subtle change. It will be a plus x by a minus x. So ln and log base e are same. So you can just write ln or log base e. So 2 by root 5 here. Now you can just write 1 by 2a. What is a? Root 3 here. And ln, which is ln or log. It's up to you. You write ln or log base e. Modulus root 3 plus what was x? It's t basically. But t was taken as root 5 tan x by 2. So I'm replacing it here only. And here also root 3 plus root 5, root 3 minus root 5 tan x by 2. Let's resolve this. 2 gets cancelled. Root 5 into root 3, root a into root b is root ab. So you have 1 by root 15. So this is the final answer. 1 by root 5, root 15 ln modulus root 3 plus root 5 tan x by 2 divided by root 3 minus root 5 tan x by 2 plus constant of integration. Now what steps are there? So this is the steps we are talking about, and you have to follow this, okay? There are certain way you can do. This is another way of doing it which I am showing you. It's not what I have done, because there are certain things which can be done in different way, but the result remains the same because you have to arrive at certain answer which is accepted. This question we are going to take in the next discussion. Till then, thank you so much and have a good one.